Hello everyone. In this lesson we're still talking about inverse functions, and we will talk about first the domain and the range of a function and its inverse. Now, to find the domain and range of an inverse function, you may find the domain and range of the original function and then switch these so that the domain of the original function is the range of the inverse function and vice versa. And this holds true in cases where these are possible. So, in a little nutshell, we have f of x, the domain is the range of f inverse of x, and the range of f of x is the domain of inverse of x, and vice versa. Okay, so let's look at a brief example. Determine the domain and range of f inverse for the given function without actually finding an f inverse. So the cool thing about it is that if you know the domain and range of the original function, and these would exist if you switch them into the domain and range of the inverse, then that is it, provided the inverse exists. Right? So let's look at f of x is equal to 9 over x plus 4. So for this f of x, 9 over x plus 4, we know that it has a denominator restriction, and that is x plus 4 is not equal to 0, cannot be equal to 0. So therefore x cannot be equal to negative 4. So our domain is negative infinity to negative 4 union negative 4 to positive infinity. And the range itself does not exist when y equals 0. So your range then would be negative infinity to 0 union 0 to positive infinity. Now, what we said about the domain and range of inverse function was that the domain of the inverse function would have been the range of the original function. So the domain here for f inverse of x would be negative infinity to 0 union 0 to positive infinity, and the range of the inverse function would come from the domain of the original function, which is negative infinity to negative 4 union negative 4 to infinity. So let's talk about domain and range of one-to-one functions, or determining if function is one-to-one. Again, previously we said a function is one-to-one if it passes both the horizontal line test and the vertical line test. If it passes both the horizontal line test and the vertical line test, that means the horizontal line would hit it in only one place as we go up and down, and the vertical line would hit it in only one place, going from left to right. So the horizontal line test in this case, for that graph, is passed, and the vertical line test is passed. So if yes, then graph the inverse. So just reflect it over this line of symmetry, and you will have the, so just look at a xy coordinates like negative 1 to 1, you go 1, negative 1, and then 0, 3 goes to 3, 0, and then 0, negative 5 goes negative 5, 0, and then just connect those lines, and we are done. Now, that is what you would do in a case like this. All right, let's move on to some applications. Word problems, real life situations. For example, the millage rate is the amount of property tax per 1,000 of the taxable value of a home. For a certain county, the millage rate is 24 mil, that is 24 in tax per 1,000 of taxable value of the home. A city within the county also imposes a flat fee of 108 per home. Write a function representing the total amount of property tax T of x for a home with a taxable value of X $1,000. So in this case, what we want to do is that we want to find what is your fixed amount of tax and what's your variable amount of tax with a value of X $1,000. Notice the millage rate is in per thousand, so it's 24 per 1,000. So if X is the 1,000, then it will be 24X. So T of X will be equal to 24X plus your fixed rate, which is 108. So that is the function we're looking for. Right? T of X is equal to 24X plus 108. Then we want to write an equation for T inverse of X. So we want to write an equation for T inverse of X. So let's do a little bit of work here. So T of X is equal to 24X plus 108. Then we want to rewrite this step instead of f of x, so t of x, we write y is equal to 24x plus 108. Then the next step is we want to interchange x and y, so we have x is equal to 24y plus 108. And then we're trying to solve for y, so x minus 108 is equal to 24y. And then divide both sides by 24. We have y is equal to x minus 108 over 24. And the next step, we will replace y with f inverse of x. F inverse of x would be x minus 108 over 24, which is really, because we're using t, we should really write t inverse of x. So that is your answer for part B. T inverse of x would be x minus 24 over 108 equals x minus 24 over 108. No, scratch. X minus 108 over 24. Right, x minus 108. X minus 108 over 24. Okay, so what does the inverse function represent in the context of this problem? So what does the inverse function represent? Okay, so the inverse function represents not the property tax, but the taxable value of the house. So the inverse function represents inverse function represents the taxable value of the house. The taxable value of the house that is in thousands. That is based on X values, X dollars of property tax paid, X dollars of property tax paid. Right? Now finally we're asked to evaluate T inverse of 2988. So T inverse, evaluate T inverse of 2988. So T inverse 2988. So we plug in 2988 for X. So that's going to be 2988 minus 108 over 24. 2988 minus 108 over 24, and then evaluate its context in the meaning in this case. And so this should give us 120, Check that on your calculator. Give us 120. And so this means that if the homeowner is charged, if homeowner is charged $2,988 in taxes, the taxable value of the home is $120,000. Is $120,000, right? So that is it. See you next lesson. Remember to like and subscribe, and we'll do a lot more of these in the future. Thank you.